Math 1332, Chapter 11, Statistics, Section 1, Gathering and Organizing Data, Video 5, Frequency Distributions for Numerical Data. Hopefully you've watched the video 4 over frequency distributions for categorical data, because there are some strong similarities between how we do that and how we do this. But there are also some key differences which we'll address right now. A frequency distribution for numerical data works almost the same as the frequency distribution for categorical data, but there is a problem that must first be overcome. Depending upon the variable, the question asked, you can get many different answers. It is possible to get a different answer from each person or object measured. Thus, we can't just assume we have one row per unique value. Let's say you asked 50 people a question and they gave you 50 different answers. Does it really make sense to have a frequency distribution with 50 different rows, all of whose frequencies is 1? That doesn't tell you how the values are distributed. It just tells you everybody gave a unique answer. But there is a way to overcome this. To counter this, numerical data is often organized into what's called a grouped frequency distribution. In a grouped frequency distribution, the numerical data are divided into classes, in other words, ranges of values. For example, a grouped frequency distribution might look like this. In the first column, we have groups of ages, 18 through 21, 21 through 25, 26 through 29, 30 through 33, and 34 through 37. And in the second column, we have the frequency of those groups, those classes. In other words, of the people surveyed, 4 people's ages were between 18 and 21, 7 people's ages were between 22 and 25, 8 people's ages were between 26 and 29, 5 people's ages were between 30 and 33, and 2 people's ages were between 34 and 37. So it's just like another distribution. But the tricky part is coming up with the classes. In order to organize numerical data into a grouped frequency distribution, you must first determine the classes, the groups. The following guidelines can help. And don't worry, we will do an example of building classes. Number 1, try to keep the number of classes between 5 and 15. Too few classes aren't very descriptive. Too many classes sometimes results in many empty classes. Luckily, in your homework and on your test, you will be told how many classes to build, so you won't have to make this decision. Number 2, make sure classes don't overlap. For example, if 2 classes are 110 to 120 and 120 to 130, which class does 120 belong to? These classes overlap because both of them contain the number 120. We need to avoid that. All measurements must belong to some class. The last class should contain the greatest value. Another way of saying it is each measurement must belong to one and exactly one class, which kind of restates what number 2 says about classes not overlapping. Number 4, and this is the trickiest part, make sure the width of each class is the same. Technically, the class width is the difference between consecutive lower limits. But this can be achieved by making sure the difference in consecutive lower limits are always the same. For example, in the classes 18 through 21, 25 through 22 through 25, 26 through 29, 30 through 33, and 34 through 36, the difference in lower limits is always 4. I want to emphasize that each class has 2 limits, a lower limit and an upper limit. The lower limits are the numbers where each class begins, so those are the lower limits. And the numbers where each class ends are called the upper limits, UL for short. So anytime I say lower limit, I mean the number that opens a class, like the ones currently circled, and upper limits are the numbers that close a class. But back to number 4, make sure the width of each class is the same. This can be achieved by making sure the difference in consecutive lower limits are always the same. I should say is always the same, but I'm going to let it slide. In this case, the lower limits are 18, 22, 26, 30, and 34. They form an arithmetic sequence. Their common difference is always 4. Number 5, The class limits are chosen based on how the data values are rounded. For example, when using whole numbers, limits should be whole numbers. But if data is rounded to 1 decimal, limit should also be 1 decimal. For example, consider the classes of 18 through 21. Hold on. Consider the classes of 18 through 21 and 22 through 25, but one data point is 21.4. To which class does it belong? The answer is neither. It falls between these classes. Classes will naturally have a gap between them, but we need to make sure the gaps are small enough so that no numbers fall in between. And the easiest way to do that is to make sure the limits of your classes have the same number of decimal places as the data points that you're organizing. So if our classes instead were 18.0 to 21.9, accurate to 1 decimal place, and 22.0 to 25.9, then 21.4 would belong to the first class. So just the rule of thumb, your class limit should have the same number of decimal places as the data points that you're organizing. Not sure what happened there. Actually, I am. All right, so we're going to take a look at an example. Oh, actually, before we do that, let's talk about how to build these classes. This list was basically what you were trying to achieve, but at no point did it tell you how to achieve it. So how do you build classes? Well, you have to have some information up front. And in this case, we're going to assume that we know how many classes that we want. In other words, how many rows we're going to build. In this table, there are 5 classes because there are 5 rows of values. So we're going to assume that you know how many classes that you want. All right, your first step is to calculate what's called the class width. And this is easy. You subtract the highest value minus the lowest value. That tells you how far apart the most extreme of your data points are. And then you divide by the number of classes. And remember, we're assuming that we know how many classes that we want. We're assuming that we know how many classes that we want. So subtract high minus low and divide by the number of classes. You'll probably get a decimal. You always round up to the desired number of decimal places. Always round up, always round up, always round up. Because if you round down, then your classes won't be wide enough to pick up the last data point in the set. So you always round up, and it will remind you to round up or to round to the next value. Then you start your first class with the least value, the data set. That makes sense. Our lowest value should be where the first class begins. Then you take the class width that you calculated in step 1, and you add that repeatedly to the lower limit, to the first lower limit, to get the lower limits for all desired classes. In other words, when you build classes, it's going to go something like this. Let's go back to the first one, and let's pretend that these classes weren't built yet. Let's say that for whatever reason, we came up with the class width of 4. We did the math. We subtracted highest minus lowest, and we divided by 5 since there are 5 classes, and we rounded up and we got 4. And let's say that the least value in our data set, least value was 18. Then we would start our classes with 18, but the way that you use the width, and this is where most people make a mistake, you don't add 4 to 18 to end the first class. You add 4 to 18, which is 22, to begin the next class. And then you add 4 to 22, which is 26, to begin the next class. And then you add 4 to 26, which is 30, to begin the next class. And then add 4 to 30, which is 34, to begin the next class. That is the role of the class width, to tell you how to get from the beginning of one class to the beginning of the next class. And that's what step 3 says. So you open all of your classes first. The upper limits for the classes should be the last value before the next lower limit. In other words, if my second class starts at 22, then I'm looking down here. If my second class starts at 22, then that means my first class should end right before it. Now, how many decimal places do I use? I can tell that these are all 0 decimal places, so the number of 422 is 21. The second class should end right before the third class begins. Third class begins at 25, which means the third class begins at 26, which means the second class ends at 25. The third class should end right before the fourth begins. The fourth begins at 30, which means the third should end at 29, and repeat. Now, when you get to the last one, you can't do the same move because there's not a next class to look at its lower limit. So how do you figure out that last upper limit? It's actually pretty easy. The last upper limit can be obtained by adding the class width to the previous upper limit. Translation. The upper limits make a pattern 2. The lower limits are going up by 4. That was the class width. Not sure what happened there. The lower limits were going up by 4 because that was the class width. But guess what? The upper limits are going by the same amount. So you could just continue that pattern. If I were adding 4, the next number would be 37 like it was over here. It's really not a difficult something to do. You just got to have a plan of attack. And sometimes it's not always obvious what that plan of attack is. All right, this video has gone on quite a bit. So I'm actually going to stop this video and start the next one. The next one is just going to be an example of this.